Hello, everyone. We are about to give our speech on how to protect your Azure App Services from promoting bad code using automated test and deployment slots. About the speakers, I am Dan Sniderman, a principal consultant starting in the development side. As you can see from the slide, I began my career in 1983. My first paid programming job when I was a college student on coding in Apple and Commodore Basic on Apples and Commodores. After graduating, I worked in enterprise computing, first in IBM mainframes and COBOL, and then I moved into distributed computing and the Microsoft platform since the early 1990s and haven't looked back. In 2004, I joined Magenic, which became part of Cognizant Softvision in February of this year. I'm passionate about developer productivity and automated processes for software development as far back as when I was working on mainframes, and I'm excited to be part of the DevOps movement. I'm married with 2 children, and I'm a professional trombonist.
Hi there, I'm Jacob Ferm. I'm a principal quality engineer at Softvision. Throughout my career, I have leveraged both my quality assurance expertise and my development expertise to build out different automation solutions for my client. Been working on multiple automation architecture projects. I have a passion for DevOps, and what I really love is helping teach people how to learn and understand different concepts and their challenges. I currently serve as the automation architect for the open source Max automation framework that has been going on for about 6 years. And I'm a father of 1 daughter with another one along the way.
So the pattern that Jacob and I are presenting on today came about working together on a project. This project is an extremely large microservice platform with literally hundreds of developers. In order to coordinate that, we are using the safe agile methodology, and there's currently 4 release trains. We mean very large. I believe there's close to 300 outside the organization to interface via HTTP or messaging endpoints. This rapid change caused a lot of problems. And what we saw was developers pushing, and I use the word bad code to try to be a headline grabber. Very often it wasn't bad code, it was just changing code. Very often it wasn't bad code, it was just changes that perhaps weren't backwards compatible. And there certainly were many cases of truly bad code bugs and recurring bugs. Other issues that we saw is that services wouldn't start due to either coding issues or maybe misconfigurations. Services didn't start at all, or didn't start in a timely enough fashion. We often saw issues with downstream dependencies. But the key problems, I think, really that were hard to avoid initially were that changes were not backwards compatible because developers weren't necessarily taking into consideration versioning APIs. And this particularly was an issue for our QA testers. So I'm going to turn this over to Jake to start talking about some of the problems that his team and his community faced.
Yeah, thanks, Dan. So I'll be talking both from a manual side and an automation perspective. So as these we'll call them breaking changes happened inside of dev environment deployment, a QA environment deployment, the nightly regression for automation would happen. Our automation engineers would come in and view the results of the test and notice a whole service was down. All of our test cases would fail. That would then turn into troubleshooting, creating bugs, bringing in multiple people to try to figure out the issue, and then have to take action on that, right? Whether it's a dev making a code change, DevOps making a configuration change, anything like that. But if we can imagine, that really hurts velocity for it in sprint, just development work commitments, everything like that. So we're talking velocity, we're talking, hours or a day worth of turnaround time to get that service up and running. And A lot of the times this is stuff that should be minimal change. If it's a new feature, that's a little bit of a different story, but we're thinking under the assumption of backwards compatibility. Our version 1 and version 2 should be able to be backwards compatible and still work while they're developing a version 3 endpoint of an API. So if those pieces break, any downstream dependency breaks, we're running into a lot of troubleshooting and a lot of effort to try to figure out what the resolution is to get it back into a running state.
And a big part of the process as well, Jake, and you can talk a little bit about this, is that from the very beginning, we had a continuous integration, continuous delivery into our dev environments. And it was changing so rapidly, we decided to do a nightly deployment to the QA environment, and your team started putting automation tests together. And so we started running a nightly deployment and then a nightly execution of those QA automated tests. And correct me if I'm wrong, but you were seeing a lot of issues of these changes coming in and deploying into QA. The automated test suites would attempt to run and they couldn't even complete. Sometimes they couldn't even start. And what types of challenges did that pose to your team?
Yeah, that's a great question there. So as Dan mentioned, that we had a continuous deployment into the dev environment, and we'll get into that little bit of a flow later on in the slides. But before we implemented any of the solution, the dev would check in code, it would run the CI process, and then it would do its continuous deployment into the dev environment. Well, if the dev went on to their new work, ended their shift for the day, they didn't go in and test that their functionality that they just checked in actually worked or is working as expected. So then when the nightly deployment happened to QA, the automation tests would run after the deployment got kicked off. After all of our microservices got kicked off, our automation would run, and then we would just notice a whole bunch of issues after that. And then that caused the automation engineers problems, that caused other manual testers problems, that now their whole service is down for the day. They can't perform any testing.
So our first approach to try to address that issue, and that was the hottest issue at that time, the head of the QA group and the head of the QA automation group really said it was really preventing them from getting their work done. So our first approach was to basically to protect the QA environment. So what we did was they wrote specific tests in the dev environment to try to prevent and detect these types of issues before it got to QA. And we implemented these smoke tests, and these are not to be confused with unit tests, which actually run as part of the builds. A unit test has all its dependencies mocked out. Ideally, your unit test should catch a lot of these, but more and more talking about integration issues, and particularly changes to the database or storage accounts or many of these other dependencies. So what we would allow is that developers could still deploy whatever code changes they want. The pipeline would run, and it would run these smoke tests at the end of the pipeline, and if it failed, it would prevent a deployment to QA. And this really solved for the QA team a lot of the issues that Jacob described, but we still were having problems with bugs getting to even higher environments, and let alone dependencies within the dev environment where team A is making their changes and they've done a break. It could be a completely valid new feature, but they inadvertently broke a contract. So service B no longer gets data in the format they expected, and that they're failing. Another scenario that's similar to this that was a problem is that we have a very high level of velocity in this project. So we validate a release candidate in QA and higher environments. Once it passes the QA test and it goes into user acceptance test, we promote the next version of the application into the development environment and the QA environment. And so as they find bugs as part of the user acceptance testing, they're promoting those code changes directly into UAT Of course, they'll cherry pick those changes into the development branch, and they'll see those changes eventually. But we are also seeing bugs being introduced sometimes into UAT. So clearly, this solution of just protecting the QA environment wasn't sufficient.
Yep. Yeah, and to kind of add on to that a little bit further, Dan. So yeah, this helped us out from an automation perspective and even a manual perspective by reducing that amount of turnaround time, because the application wasn't deployed. So the previous release was always still running in the QA environment. And then that helped us figure out and triage issues in dev versus later on during the different environment process. As you were talking about with the release versioning strategy, to kind of add on to that a little bit more, is when we do our release candidate for a specific version, we stop doing that specific release in the lower environment. So we're getting into UAT or stage with our specific releases, and we do our validation with that. But we don't have that full set of regression testing happening in those higher environments, because that's really, we're in a clean state. The business users are doing their acceptance testing and everything like that. So we could potentially be missing critical issues and critical bugs that are happening that can be uncovered right away, versus waiting for a business user to create a bug, troubleshoot with different teams, and having that turnaround time as well.
So still facing this issue, we got together as a group and analyzed the issue and came up with a solution that's working very well for us. And there's two major parts to this solution. The first one is the use of deployment slots in Azure. Deployment slots are a feature in Azure App Services that's essentially a virtual website deployed on the same virtual hardware as the primary site. So the slot that we had been using all along is known as the production slot. This is the terminology within Azure. It's a little bit confusing because you also have a production environment. There's a production slot in the dev app service, the QA app service, so on. Each has a production slot, and you can have several other slots depending on which tier of Azure you're using. This is not available on the free or shared tiers. You have to use the standard and premium tiers, and you'll get a certain number of slots. There's no additional cost to this because you're sharing the same hardware. Deployment slots can be used for a number of things in addition to the methodology that we're discussing. It's often used in zero downtime deployment strategies, A/B testing, blue-green testing, and so on. And so again, you will see similar features in AWS or other clouds. You could probably even look at following a similar process on an on-prem deployment. Another benefit of this is that the downtime is much faster in your deployments because you're deploying to an alternate site, and your primary slot is only not available during the swap, where you're swapping from one slot to another, which happens relatively quickly. So you can also have less downtime in your deployments. You have separate code bases in each slot, and you can have configurations. Some of your configuration settings can even be separate if you need to test that. There is a link in the slide to the documentation on Microsoft's site for deployment slots. In the Azure portal, this is what deployment slots look like. If you have an app service provisioned, you'll have this tab on the left saying deployment slots. And through the portal, if you wish, you can add a slot, and each slot is shown, and the load balancer features are shown off to the right. You could use a blue-green testing type situation where you could have 50% of your traffic going to one or the other. But in our case, we're always going to have 100% and 0 between two slots. And the key part of implementation, as you see on the bottom of my screen here, the slide, is that the production slot as expected has the app service name.azurewebsites.net as its URL. And the smoke test slot, which is what we're naming our slots, is the app service name -smoketest.azurewebsites.net. So in addition to using deployment slots, another important feature that we are using to protect our environments is requiring each service to have a health check API. This is a standard microservice pattern. There's a very popular website that defines standard microservice patterns, and you can see I put the URL to that. It's called the health check observability pattern. And the idea is that you expose an endpoint to your REST API that will return whether the service is in a healthy state or not. This requires specific coding by each development team, and it requires enforcing shop standards, which of course you should be doing on a project of any side. And this could of course be implemented in any language. We do have some in our application. We do have a handful of services that are written in, say, Java or Python, and they as well will expose a health check endpoint. And we use just /health. And in addition to knowing that the site is up and running, it should check that it can reach all of its routes. It should return, it should check all of its dependencies. If it has a database, it should make sure it can connect to the database, a storage account, a service bus, et cetera, et cetera. When you check, it should make sure all of these dependencies are available. And then it should return a parsable object. We use JSON so that any consumer of that endpoint can report whether it's healthy or what part of the dependencies or what features are making it unhealthy. And additionally, we do, and you should look into providing additional metadata, the semantic version of the service, its build number, build date, are examples of metadata that we provide on our health check.
Yeah, and a few other things to add with that health check that's kind of helped us out through the process is think about it from a testing perspective. Well, if I come in as an automation engineer and review my automated regression test from the previous night, and I notice everything is throwing a 500 internal server error, one of my first steps is just to make sure that the service is up and healthy. So I can go in and hit that health endpoint and validate that all the dependent service checks are working, my database connection's good, everything like that. What else you can do is you can, for us, we've tied it into Azure and utilizing workbooks and reporting inside of Azure to get that information as well, so that something in the production environment can continuously trigger and watch that information and create triggers and notifications happening when the services are unhealthy.
So given that the health check has been implemented, we have a script that we use in our pipeline to exercise the health check. And it's not just sufficient to check the health check on your site in general, but in the case where you have scaled out and you have multiple instances of your service that are always available at a minimum, you need to check each instance that it's healthy. And one of the reasons this is critical is because we have found one of the issues that we had in our automated testing is we would get intermittent errors where the site seemed to be up and responsive, but as the automated tests were executing, the load balancer would split that among the instances, and some of the later instances, particularly in a large scale service that had 4 instances at startup, the third or the fourth instance was not ready to receive requests, yet the load balancer was sending requests there, and it was intermittently causing tests to fail. So we wrote this script, and it required a good amount of research because some of these, I'll show one thing in particular, was not well documented, And we had to do a lot of detective work to figure out how to do this. So I'm going to share that with you today. So this is at a high level, the majority of our script that's in our pipeline that executes the health check. Ultimately, you're calling an endpoint, which should be a simple call in any scripting language. But the interesting parts here is, first of all, we need to get all the instances of an app service. There could be one, there could be many more. So we use PowerShell as our scripting language. And in particular, if you look at the the third to last line here, I'm getting all the instances by using the get az resource commandlet and passing it in a resource type of Microsoft websites and instances. And I will get an array of all the instances, which I can then iterate through in a for each. Formatting the URL. Obviously, I talked about slot names, so you can see my top line. I'm checking if it's the production slot or not. We don't hard code smoke tests since that's what we use. So in the future, if we had others, we support that. So you can see it's either got the service name or service name dash slot name. So here is the really difficult thing that we had a hard time discovering until we found out that the Azure App Services allow the use of a cookie where you use the ARR affinity cookie name and you pass the instance ID and you add that to your session object as part of your request, and it will route that request to that specific instance. So as you can see, it's just a simple invoke REST method, including that session object in the web session parameter, with just a simple get to the health URI. And additionally, you can pass in a timeout. So we're going to enforce an SLA. We require all of our services to have a minimum currently of 90 seconds to respond, or it's not considered healthy. And we expect the developers to determine why it's not starting up in that time frame, and we consider that an unhealthy service. So Jake, why don't you go over the exact flow of how our pipelines work in the dev environment?
Yeah. So this is focused in on the dev environment as we kind of talk through and kind of build everything up. We'll go into more detail later on in some other environments. So our first step here is a dev checks in code into the Git repository. That will then trigger a CI build to build up the artifacts, store the artifacts needed to deploy out to the actual site. So on this next step here, we actually deploy the code out to the smoke test slot. Once that involves stopping the slot, deploying the code, and starting the slot back up. After the start happens, we run our health checks that Dan just explained. We make sure that our instances are up and running on the smoke test slot. After that, we go and run our smoke tests. Now I'll go through all the different flows here, but this is our core integration test to make sure that the newest code deployed change happens. So this is inside the smoke test slot. It is an example of release 2, and the production slot is release 1. So let's go with the smoke test failed. So we'll go off to the left here. What we do is we leave our smoke test slot running, and our production slot stays running with the older working code. So the smoke test slot is on release 2. The production slot is under release 1. And then we can report the results to allow the developer, the automation engineers, the manual team to go in and read the results and figure out what happened. Now, if we go back to that first initial smoke test, we'll go down to the passed route now. So if all of our smoke tests pass, we swap the slots. We perform that action, which will kind of show that implementation later on in the slides. But the smoke test slot now turns into the production slot and vice versa. So now our production slot is on release 2. Our smoke test slot is on release 1. We'll then run those health checks against that production slot just to make sure that everything is started up and still running. And then we'll run the smoke test again. And we'll get into it here in a little bit on why we run a secondary set of smoke tests. But if the tests failed, we actually swap the slots back to make sure that we're still in a working state so that we don't prevent other developers, other testing members from being blocked because that new deployment is causing an issue. So when we swap the slots back, a smoke test slot will be under release 2 and the production slot will still be under release 1. And we report our results back on that so people can do the triaging. If we go back and everything is passed, what we do is we turn off the smoke test slot. Reason is it's running older versions of the code. It's taking up resources, even though it's minimal, it's still utilizing the app service and the resources built into that app service. So we turn it off because it's not used anymore. Release 2 is in a good working state. And then we report those results so that we can do additional reporting to show pass failure rates with it over time. Dan, do you have anything else to add on that?
I think that we covered that pretty well. Just the one thing I will mention too is an important fact is, like I said, if there is any failure, that old slot, the smoke test slot, has that new code that's not available to the normal users using that URL as expected, but a developer or QA person, operations person, particularly in higher environments, that is up and running, so they can do any troubleshooting they need against the live app service and use all of the tooling available for debugging against the live app service. It's just only if you specifically put in that dash smoke test URL. And as Jake mentioned, if the code succeeds, there's no reason to have old code around, even though there's no charges. You are potentially putting some drain on the hardware, so there's no reason to leave that up and running, so we stop it. We don't remove it because there's some extra time in creation and destruction, so we figure and there's no cost for it, so we just leave it there. So in the next deployment cycle, when we deploy to it and start it up, that's a little bit faster. Now, one of the things that Jake mentioned and you saw in that flow is that we actually run the smoke tests twice. We run it against of course, the smoke test slot with the new code to make sure it's valid. But we go to the extra step of running it a second time after we've done the swap. We put a lot of thought and conversation into this to determine whether it's necessary, because obviously the downside of this is that you're increasing your release process, particularly in cases where you have a lot of smoke tests. Some of them I think can run as long as 10 to 15 minutes. I think we try to keep it down for that. I think that's some of our longest ones. And so the downside for that is it does take longer. But we decided we want that extra level of protection, and it's actually been very helpful in a number of scenarios. Particularly, there are times when there are configuration changes that maybe weren't properly applied to both slots. More commonly, we're finding issues like because the URL is different, there are certain things like webhooks and maybe event subscriptions that are specific to a particular URL, so that when it's in the smoke test slot running the tests, it doesn't have these other load being applied to it. So we've had a case, for example, of once that service came up after being down and coming up again, restarting in its production slot name, new messages coming in from an outside source overwhelmed the level of scaling of the service, and the developers hadn't handled it so that it could share processing with inbound HTTP requests while processing those messages, that the service was an unhealthy state. And in that case, the second test would fail, and we would put the code back to the state where it could handle that scenario. That's probably one of the most common cases. But I want to, Jake, before I move on, are there any other cases that you've experienced where the second smoke test was particularly helpful?
Yeah. So one of the things with the smoke test slot is we're hitting that app service directly when we're running our automation tests. So we're hitting that app service directly, but when we get into the production slot, you could have something like an API management tool, something like APIM that Microsoft offers in front of inside your production slot, something that the UI uses to handle traffic and do some firewall implementation. So we have noticed other configurations where even though the service at endpoint was inside the smoke test slot inside the service deployment, the new endpoint, that actually wasn't imported into APIM, and that actually caused an issue and caused it to fail because we couldn't hit that API during that time.
And so I just want to say that this isn't necessarily a best practice for every type of project in user. And I think in many cases and other projects I've been on where I wish I had a pattern like this available to me, I don't know that I would execute the smoke test the second time. So I think if you're considering this approach, you should put a lot of thought into how you want to implement this and whether the increased time to run these tests twice is useful to you. If you may not have any of these types of scenarios where it's overkill. And I think that's a perfectly acceptable decision to make on many projects.
Yeah, let's talk about kind of QA automation testing and building out our test cases. So for this specific scenario, we're using C#, MS Test, and Azure DevOps for our test cases. That allows us some additional benefits that you might not get in other pipelines. But what that allows us to do is link our automation test cases to our manual test cases inside of ADO. That allows us to do different reporting and different options to view that it pass-fail information over the course of the test case, over the course of the application. When building out our automation test, the smoke test, we want to make sure that these are quick and shallow tests that test the actual core functionality of the app, the service, or the functionality that we're testing. So we're not doing full end-to-end flows inside of our smoke test. We're running a get call to make sure we can get data. We're running a post call to make sure that we can create data. We might do a UI logon flow, but like I said, we want to make sure these are quick and APIs are super quick. And with that creation, using ADO and the test plan in there, we can generate different suites based off of different configurations that we want, where we would have a dev smoke test suite, we would have a dev regression suite, a QA smoke test suite, a QA regression suite, so that we can pick and choose what tests we want to run where, and figure out if we want to run these in the nightly regression or against a smoke test slot. So what we do with our pipeline variables is we actually pick and choose what suites we want to run against which specific service and which specific environment. So on the right-hand side there, you see that there's a smoke test suite, and you can see a little bit of a JSON snippet there to show the different suite IDs that we're putting in. Now, I want to add a little caveat onto that smoke test suite. The reason why we had to do that is inside of Azure DevOps, under the UI for building pipelines, there is actually a bug or limitation that you cannot actually parameterize which test suites you want to run. So this was our workaround for that. But if you use something like a YAML pipeline, there is no issue putting in parameterized test suites in there. So we had to do a little bit of custom extra work in there to make it work so that we can configure different test suites for each different environment that we're running against, and as well as do different reporting on this. So as this process is going on in that flow that I showed, I showed report results. So what happens with that is that our automation engineers, our dev, get notifications that their deployment failed, and they need to go and troubleshoot and take action. They'll go in, see what tests failed. We have logs available that show us what test ran, and we get logs in with it too. What was the post request? What was the body of the post request? So it makes it easily reproducible so that we can give that information to the developers and allow them to figure out what happened within this latest deployment. So now getting into this, we've been really focused in on the dev environment here. Well, we actually took that dev environment implementation, and what you saw in the previous slide with the test suite configuration is we actually brought that out into multiple environments as well too. So we actually run this same smoke test process through dev, QA, UAT, and stage. And what that allows us to do is it allows us to validate that our critical functionality is still working in between each deployment and each environment. It allows less downtime. It makes sure that our critical pieces are working so our business users aren't finding these issues. And how we did that was we were able to figure out different configurations so that we can run these tests based off of different configurations in different environments. One of the kind of negative side effects is that as you start getting into higher environments like a UAT or stage where they're using actual production instances and everything, is that the automation code might not be able to utilize that. Let's say validating a notification went out with an email. In the lower environments, we might have a tool to send us an email into a database or into an application. But in the higher environments, it might actually send out that email. So we need to be able to tailor our tests and our smoke tests to handle those different situations. As Dan talked about, in terms of execution time as well, that is a big thing, because as we're doing releases in between UAT and stage and into production, is that we want to make sure that those don't impact the people, because you usually are doing deployments during the weekend. You don't want to take up everyone's weekend waiting for deployments to happen. So we want to make sure that our run times for our smoke tests are as little as possible. And one of those other things that we do to help that is we run tests in parallel. We run tests under method level parallelization to be able to run 4, 8 tests at a time. And then the last point is, if running in a production environment, you need to make sure that you're not going to be messing up data in actual production environment. So maybe you have to tailor your tests in the production environment to only gets versus a post or a put on an API aspect to create or update data. Dan, anything else you want to add there?
So the only thing I did want to add, another pain point that we faced, starting up this process was a little bit difficult because obviously you're not going to start out with tests in all your environments across all your services. You start with some of the key services, for example, an authentication service. If you can't authenticate, the whole system is down. And when you're talking integration tests, one of the big pain points we saw is that you're often relying on data from another service to just have basic data that you're formatting to do your call to your main service. And an example of this is you might need to put a country code in for a request to authenticate. And if you have another service that gives you a list of country codes, so you want to get US and you expect it United States and you expect it to be US, if a developer in that service changes their contract inadvertently so that the short name becomes the long name and they're returning USA, for example, instead of US, my authentication smoke test will fail because I'm passing in the wrong value. So when we first started this, we had a lot of frustration on the first teams because we hadn't yet written the smoke tests on the upstream systems. And so they were getting a lot of what they considered false negative failures because they were getting data upstream. And we just said, trust us, this is going to work in the long run, because once that geography service had its test implemented, in particular, we said, go to them and make sure they have a smoke test saying, when I retrieve country codes, it's going to be in this format. Once they had that smoke enhanced to have their smoke tests, if they were to institute a change like that, the geography system's smoke test would fail, and that code never got in there, and the authentication service never saw errors of that type. So this can be a difficult process in the early stages, but once we got more mature and we had these tests built out, that pain went away, and the developers in those earlier systems started reaping the benefit of that as well. So I wanted to show going from that process flow to implementation. I can't, with the time permitted, I can't go into too much detail, But one of the things that we recommend and insist upon is the use, in our case, of task groups, since we're using release management. In the YAML pipelines, they have templates. I know GitHub has a similar concept. All of the tools have a similar concept of some sort of templating, so that all of your deployments of all of your services are done in a completely consistent way. And so even though we have, say, I don't know how many services we have now, 30, 50, very many of them, they all use the exact same task group and are deployed the same way. And so you can see here this, if I were to go back to the other slide, you can see this flow. You know, we get our artifacts containers, we get our artifacts for the tests. We create the slot. This is idempotent. If it already exists, it just runs very quickly and sees that it already exists. We stop the service, we deploy it, and then we start it. And this is all parameterized. So if this environment didn't have that snippet of JSON in the variable that Jake showed, so because we haven't written the smoke test yet for this environment / service, it's going to go directly to the production slot at this point. And it knows it'll run the health check, but it knows there's no test automation.
Cognizant Softvision brings a design and product-led mindset to
steps. But in the full flow that we showed you, as you can see, we run the health check, we run the first smoke test, we set the variable to show whether it succeeded, we swap the slots, we run the health check, we run the second smoke test, we set the variable so we know whether or not we have to either swap the slots back or stop the smoke test. And just a little bit more details of some tricks that we learned in Azure DevOps release management. There's no out-of-the-box way to know if one particular step succeeded. You pretty much only know whether the succeeded verb, which you can see under custom conditions, just tells you if everything succeeded. So we know it would stop before it got here if anything failed. So we can set this variable here saying the first smoke test is true in our little PowerShell inline script you can see under script. We have our custom condition to actually execute, whether we actually execute this or not. So if it failed in the previous step, it wouldn't execute that script, and the first smoke test success variable would be false. So as we get to the swap slots, you can see here, when we check the variables about halfway through there, you can see we have an equality check against the first smoke test success to be true, and we also check to make sure it's healthy. So that's essentially how we implemented this. Jake, any last chance here on what you'd like to talk about on the implementation?
Sure. Yeah. And Dan, just to reiterate from what you said before, is that this was not an easy effort. As it took a bunch of business users, POs, developers, architects, automation engineers, everyone to make this whole system work. But once we got the flow going and got every service updated with the smoke tests, it really has helped our quality and our velocity with this project.
Yeah, we had major buy-in from management on this project. The release train engineer of all the trains, the head release train engineer, was a big proponent of this. We had a series of meetings. We iteratively designed and discussed this. We had a lot of stakeholders in that meeting. So this isn't something that, as much as I'd like to say Jacob and I on our own came up with this brilliant idea, it was a very big group effort to design it. Just Jacob and I were tasked with implementing it, and we had others as well help us. And we feel very confident that this major effort has paid off very significantly. I would say easily hundreds of man hours have been saved by having this process in place. So thank you, everyone. And we have some time for question and answers if there are questions.
We don't have questions right now, but we can wait a few minutes.
Okie doke.
We have a lot of reactions, pull reactions.
Great.
Awesome.